So let's get started with today's problem. So what does it state? Write a program that determines the smallest number of perfect squares that sum up to n. Okay. And a few examples are, if n equal to 4, return 1, indicating 2 square is 4. So we just have one perfect square. So we're returning 1. N equal to 17, return 2, indicating 4 square is 16 plus 1. Okay, so you can use 1. For 17, you can do 16 plus 1. Okay, and given 18, you could do 16 plus 1 plus 1, which would make it 3 squares. But an optimal way to return 2, we would need 3 square plus 3 square. Okay, got it. So we are supposed to return the smallest number of perfect squares that sum up to n. Okay, so let's see how we would do that. So let's say we have a number, they have provided us with 17 or something, right? So if you have given me 17, I need to find out the perfect squares that add up to it. So this perfect square list can be something like 4 square plus 4 4 is 16 plus 1 square. This is one solution. Or we could have 3 3s are 9, right? We can have 3 square plus 2 square, correct? Because we can't use another 3 square because it will become 18. So 3 square plus 2 square, so 9 plus 4 13 plus 2, right? So we have 8 plus 9 17. So but this is not the least. We are using 3 perfect squares in order to get the result what we need, but we can get 4 square plus 1 square, that is 2. Okay, in order to solve this, we still need to find out 3 square plus 2 square plus 2 square, but then later we can realize that no, 4 square plus 1 square would be the perfect solution. Okay, so we need to find all possible solutions and find the minimum of that which would satisfy the requirement, right? Okay, so the input, so the input for this problem would be something like so the input would be 17. Okay, we'll take 19 for this input. And step 1, what would be the steps that we would take in order to resolve this? Step 1 would be how many squares are we supposed to calculate? We cannot calculate like everything, right? Like all the squares up to 19 is useless, because let's say 18 square 256 will not be what do you say, required for this, because we need to sum up to 19 only. To get 19, how many squares first do we need to calculate? I think if we calculate square root of 19, right, would be the closest. In this case, it would be 4 point something, right? If I'm not wrong, let's check, verify that. So we have square root of 19, square root 4.35. Okay, so we get 4.35. We'll assume that we are working with only integers, so we will round it up and we'll calculate squares up to 5. That means we'll go till 4 only, right? Do we need to go up to 5? No, I think the lower minimum value of this would be suffice for us. So let's not go up to 5, we'll go only up to 4. So the integer value of this is sufficient. But what happens if we go till 24, right? 24 would be very close to 4.9 something, right? Because 5 5s are 25, so it should be something very close to 9. Yeah, I think at that time also calculating the squares up to 4 is sufficient. Okay, step 1 is calculate how many squares we need, right? So we know, given a number, find the square root, we find the square root, number of squares required, number of squares. This would be step 1. In this case, we know we have 4 squares required. Then for all the squares that we have. Let's say when you calculate for 4, right, the squares would be something like 1, 4, 9 and 16, right? These are the perfect squares that we can use in order to get, let's say, 19. Our intention is to get 19, so we have been given only these squares. If that's the case, let's move the screen a little bit. Let's move it up to the left side. So now to get 19, what we could do is something like first we can start from the beginning, from 1 to 19. We can iterate over it and see to get 19 what are the squares we need. Like in your first step we can say let's say we iterate from 1 to 19, right? 1, what is 1 square is 1, so 19 minus 1 is 1 minus 19. No, it will be, because the index we are calculating for the position 1, what is the minimum square. Like we know to get 1 we need 1 square, for 2 we need 2, because it will be like 1 square plus 1 square is equal to 2, correct? But 3 would be 3 square. 4, when we come to 4 we get to know it is just 1, because like we get to know 2 square is 4, so it's 1. Or it can be 1 square plus 1 square plus 1 square plus 1 square, so that can be also 4, right? So you can have two options, out of which we will choose the minimum option, that is this. Like to get 4 you have to use this. So we'll keep calculating all the minimum squares up to 19 till we hit 19. That way when we come to 19 we would be able to tell what are all the squares that are required. Like we would say to get 19 in this, let's minimize it once again. Right. So to get 19, now we could say that, hey, first I'll do 19 minus 1, because it should be a sum of perfect square, right? So I'll do 19 minus 1, that is 18. What is the minimum value of getting 18? What is the minimum value of getting 18? Then comma, minimum value of 19 minus 4, because it's another perfect square. So I should say what is the minimum value, minimum number of squares that I need in order to get 19 minus 4 would be 15. Okay. Or what is the minimum value for 19, minimum value to get 10, right? Because it would be 19 minus 9. And similarly minimum value to get 19 minus 16, that is 3, correct? So we already know 3 is 3 squares, like the minimum we need 3 squares in order to get 3. So we can say that 19 can be achieved from 1 square, that is 16, plus 3. So there is 3 square, 3 plus 1. There is 4 squares we can use in order to get 19. But is there any other better option over here? Like to get, like you can use 10. No, 10 would be ideally, the minimum for 10 would be like 3 square plus 1, right? So this is one perfect square and this is one perfect square, like 9 plus 1. So even for to get 19 we could use 3 square plus 1 square plus 3 square, right? Makes sense, correct? 9 plus 9, 18 plus 1, 19. So just 3, using 3 perfect squares we are able to get 19. Whereas if we had gone with 16 plus 16 plus 3, it would the last one, it would not be the optimal one, right? So this we can arrive at the solution, but by finding all the minimum squares up to 19, correct? That makes sense. No, right? Like to get 19 square we need to now calculate 19 minus 1 square, correct? I'm just reiterating so that I understand. Yes, so this would be 91 minus 19, then it becomes 4 minus 19, 19 minus 4, sorry, 19 minus 4. So this would be 19 minus 1, 19 minus 4, 19 minus 9, 19 minus 16, right? So we can choose, find out the squares, because when you subtract you will get to know this is 18. since I would have already calculated 18 over here, so I can get to know whatever is the minimum for that. Similarly for 15, similarly for 10, and for 3 also. So this seems like an approach we can take in order to resolve this. Okay, so let's come back to the problem. Copy the question. 1 second. Right. Copy it. Okay. So our problem statement will be def get minimum squares required, square count. Right, we'll have this function which takes in a number and returns back some value. So for now, let's say return 0. Okay, we need to return some value. Okay, from the like how we were planning to solve this, first is we'll find the square root, and so that we get to know how many squares we're supposed to calculate, right? Like 1, 4, 9, 16. This we know because they are told it should all be perfect squares that sum up to it, right? So this would mean that for a given num, we'll find this halfway. Halfway is equal to number square root of this number, right? So we'll say the integer of number to the power 1 by 2, that is nothing but 0.5, right? So this would be, if I send 19 square root would be something close to 4 point something. So integer of 4 would be 4. So I would need to calculate all the squares till 4, right? So let's say I have a square value. Squares is equal to I star I for I in range 0 to halfway. I need 4, no? So when I go from range, I'll get 0, 1, 2, 3. I need even 4. So let's say I go up to 4. So if I'm right, the squares value should be something like 0 square, 1 square, 2 square, 3 square. Correct? But do I need 0? It doesn't make sense, right? So we'll start from 1 only, because 0 square will be 0 only. So I don't need that over here. And we are not considering that as a perfect square. Like we would not need to subtract with 0 square also. So okay, now that I have all the squares up to the point, now I need to find out this subtraction, right? Like find out to get 1, how many minimum squares I need. Similarly for 2, how many would I need, right? So let's initially have minimum squares required. Required is equal to, we can have a map, but using so basically what am I expecting here? I am expecting something like this. This minimum squares, right? Minimum squares required, it should be equal to, like to get 0, I mean to get 1, it is 1, and to get 2, it is 2. Similarly for 3, it would be 3. 4 would be 1, because 2 square is 4 in this case. So we would have that, right? And 5 would be 2 square plus 1, right? So you would need 2. Basically this would be 2 square plus 1. So that's why you need 2 perfect squares in order to get 2. So I need to store all of that in one map, no? So that's why but instead of using a map, we can use an array where the indexes are nothing but the keys for this, like list index. So let's say I for I in range, I can start from 0. I need 0 to what do I need? Go up to, I will go up to num plus 1, because I need, if you give me 18, like, or 19 is the value whichever I'm interested in, I need to know how up to 19, right? Like how many squares are required for 19. That is our question. So that's why we need to go up to 19, and I'm filling it by default with I, because the worst case scenario, 19 would require 19 squares, perfect squares, in order for the solution, right? Like this would be the worst case scenario. Why would that? Like we could use single, like 1, right? We can use 19 ones in order to add up to 19. So that would be our worst case. we are supposed to find out the minimum, like if we can optimize that 19 to something smaller so that we could return that as a solution. So solution would be something like return me the minimum squares required for the number that you are looking for, right? Now our intention is all of these values, like let's say I print this, print say we have this, the minimum squares required are this, right? Let's say we were going to print this and we'll call this function just for testing purposes. We'll call it with 19, save it, right? So you can see to get 0 it is 0, to get 1 it would be 1, 2, 3, 4. It's considering it is 4 because it thinks that 4 times if we add up 1 it would be make it 4. So yes, so this is like the base case, and if we return back for 19 it would be 19. So we returned some answer, but it's not the best answer as of now. Let's go to optimize. Now our intention is for index in range of I need to go till this number, right, in order to fully find out what is the minimum value. So let's say for index in range num plus 1, right, and I'm starting from 1 onwards, right, because I don't need to optimize 0. 0 is 0 only, and 1 would also be 1 only. So actually I can start from 2 itself. No, let's start from 1, because when I go to 1 it would be 1 only. Actually it will not make a difference. I can start from 2 because 2 I have to compute, right? It will be 1 plus 1 only. So now I need to say minimum squares required for my index, that is in my case when I start from 2 it will be 2, 0, 1, 2, 2 is equal to find me the minimum of, right, find me the minimum of the minimum squares required of, now I need to subtract this index with the perfect square. Like I have to now subtract it with 1469, right, like what we just calculated over here. So squares would be something like would be like 1, 4, 6 and 9, right? Sorry, 1, 4, 9, 16, right? What we are doing over here is we are checking when we take an index we subtract it with 1 because it's a perfect square. If we can get a 0 that means it's done. If it's not, then go to the next one, keep going till you can keep subtracting it with the perfect square. So for that I would say a minimum of minimum squares required minus perfect square for perfect square in squares, right, index minus this. So when it comes first 1 it would say okay, my index is 2, I'm starting with 2, so 2 minus perfect square first value is 1, 2 minus 1 is 1. So what is the minimum of getting 1 squares? To get 1 would be 1 only, so it would be 1. In the next iteration it would go to index would still be remaining as 2, perfect square would be 4, so 2 minus 4, 2 minus 4 would be minus 2. Okay, we would need an if condition here. If index minus perfect square, right, index minus perfect square greater than equal to 0, only then you calculate the minimum, right? I think this would make sense. So if we have this, we're saying that only when it is greater than 0 continue it, or else leave it, right? So now what we are doing here is we are calculating all the minimums like 1, 2, 3 and going up to 19. And do we need to do anything else? We are calculating the minimums for each number and we are finding out the minimum from all of that. Okay, I think this should do it, no? Or am I missing anything? Nope, this should do it. So let's save this. Let's test out the problem. If name equal to main print squares required is equal to minimum square count of, let's say 19. First we're going to send 19. Color is none. Minimum squares required to get, so we'll say num is this, right? So let's shoot the problem, check. It's coming 0. Okay, why is it 0? So that means something's probably going wrong. Okay, this line, right? I think we're missing something probably in this line. So let's print it out. Let's say that for every time when I am in this array, let's see what is my index. What is the name of the function? Minimum square count, right? Minimum square count. The index and the minimum. No, we will not find minimum. We'll just find squares for that are squares required. We'll call it required. We'll come to what is squares required. Squares required would be this entire logic, right? Whatever we built, we'll put that in one new variable called as squares required. Squares required UIRD is equal to this, right? And we are printing that over here, and we will find the minimum of that. Our intention here is to find out for each index what are the squares required. Like expectation is when you go to 4, you should see 4 comma 1, right? Because 2 square is 1 and 2 square is 4, so it will be 1 perfect square, and 4 also, 4 being because 3 square plus 1, so 3 plus 1, and to get 3 you need 3. So right, so let's print out the problem. Okay, wait a second. This itself is wrong, right? Like to get 2 it should not be 1. To get 2 it should be 2, because 2 you would get by adding 2 ones, right? In this case, so so what we would do is we would probably add one more, right? Like 3 should be, it should be 3, right? Why is it 1? It is 1 because, okay, so when you go to index 3 you would subtract this value, right? Like index would be 3. 3 minus 1 would be perfect square. First perfect square that we are having here is 1, so it will be 3 minus 1. It will say, okay, what is the minimum value of 2? This value will be 2, so it look at this. For 2 already we have calculated it as 1, which is wrong, right? Like 2 should be 2. That's why everything below it is also failing. Okay, when you go to 2, let's come to the first scenario. When you come to minimum squares required, index minus perfect square. So this will be 2. 2 minus 1 is 1. So minimum index to get 1 would be 1. So it's just stopping there, right? It's not incrementing. It should be 2, right? So we are going to add one more to that, so that first time when you ask 2 minus 1 would be 1, and not just add that, because to get 1 we had to get one more perfect square, no? So it will be 1. So I think this should do it in that case. Let's check it back. To get 2 you need 2. Okay, so if you solve 2, to get 3 also should work similarly. To get 4 we are having either 4 options, or we can get one option only. This one is coming because 2 square is that. And to get 5 you can have 2 square plus 1, right? Yes, 2 square plus 1, or 1 square plus 2. That's why it's, I think it's having 2 different 2s, 3s. We could optimize it by putting it in a set also. That way this length would always be, minimal. But anyway, in our case here, we are just finding the minimum out of that, right? It's not going to increase that much. Correct. Yeah. So this if we have, and what is the value for 19 we are returning? It's 3. 3534. Okay, I think this should do it. So what was the question? In the question they asked us return 18, we should return 2, right? Let's try for 18. 18, actually it's 2 over here, so we'll get back as 2 is the answer. Let's try 24. 24. So let's run that. 24 is 3. So it would be, how would we print 3, right? To get 3 we would say 4 4s are 16, right? So we can say 16 plus 4. No, that would not make it 24. To get 24, closest I can go is, how about 9, right? 9 plus 9. 9 plus 9 is 18. 18 plus 6, is it? No, 18 plus 6 doesn't. But to get 6 again, I would have one more. How do I get 3 for 24? To get 24, let's write that down and verify if our answer is right. To get 24, you can have something like 9 plus 9 plus 6, right? To get 24, or you can have 16 plus, oh, you can have 16 plus 9, right? So wouldn't that make it like 4 square plus 3 square? Sorry, 16 plus 9 is 25. My bad. It should be 8. So let me undo that. Or else what else options do we have? We have 4. We can use 4 plus 16. 4 plus 16 is 20 plus 4. Okay. So this is how you can get 24, right? 20 plus 4, or 9 plus 9 plus 6. Yes. Yep. It is possible using 3. You can't get it using 2, because 25 you could get it using 2, but 25 5 square is also there. Yes, so we can accept the 25. To get 24 you can get this 3 or this 3, right? Because it's either 996 or 16 plus 4 plus 4, right? Yes, so I think that solves this problem. Okay, thank you.